All right, welcome back to differential equations. We are going to continue talking about inverse Laplace transforms. I forgot there's one I really wanted to show you before we move on to doing solving a differential equation with it. So there's going to be two examples in it. One is just a find an inverse, and the other one's going to be solving a DE. So here's the one that we said we're going to find the inverse Laplace transform. Okay. And here it is. We have an S over, what is this? S minus 3, S minus 4, and S minus 12. Okay, now what we're going to have to do is we're going to have to do partial fractions on this. Okay, so here we go. We have an A over an S minus 3 plus a B over an S minus 4 plus a C over an S minus 12 is equal to an S over all of this stuff. Okay, now we're going to clear the fractions. So we have A, S minus 4, S minus 12 plus B, S minus 3, S minus 12 plus C, S minus 3, S minus 4 is equal to S. Okay, I'm going to go ahead and multiply this out. And again, I know there's an easier way. If you wanted to set S equal to 3, you would solve for A. Okay, if you set S equal to 12, you would solve for C. So there is a way of set S equal to 4, solve for B. It's actually going to be a little bit faster. S is equal to 12, solve for C, and 3, S is equal to, what do we take? We did 3, 12, S equals 3. Solve for A. All right. And that's a very legitimate way to do this, and I encourage you guys to try it on a couple of them, see what you like. I never really got into this method, but you know, it is quite useful. And there are times when doing this is going to be way more helpful than doing it any other way. But sometimes, like with repeated roots, you can't do this. Okay, so we'll say this is S squared, 4 and 12, that's going to be 16S, plus 4 times 12 is 48, okay, plus B, okay, and then here we have S squared, minus 3 minus 12 is minus 15S, right, 3 and 12 make 15, and that's going to be a plus 36, and plus C, and then we have S squared, 7 and 4 is 7, or 3 and 4 rather is 7, plus 12, and that is equal to S. So pulling these apart and equating the coefficients for my S terms, S squared terms rather, we have an A plus a B plus a C is equal to 0. For the constant term, we have a negative 16A, right, that's negative 16A, minus 15B, okay, minus 7C, and this is equal to the S's on this side, which is going to be one of them. Okay. For the constant term, we have 48A plus 36B plus 12C equals 0. So for those of you who have linear algebra, right, what we're going to do is we're going to make a matrix. For those of you who have not had linear algebra, all we do is we write down the coefficients. So this is like the A route, the A column. So we just have a 1, negative 16, and 48. For the B column, we have a 1, a negative 15, and a 36. For the C column, right, we have 1, we have negative 7, and a positive 12. And then we can make an augmented matrix and put our 0, 1, 0, our answer on the other side. Okay, and you could look at this and rightly say, oh no, we're not doing this. And I would agree, because this is a mess. You do, however, like they recommend, that you would get to 83, 84, and you have a matrix button on your calculator. Second function matrix. This is known as a 1, 2, 3, 3 by 1, 2, 3, 4 matrix. Okay. What we're going to do is I'm going to show you how to put this in the calculator and how to solve it, so that I'm not expecting you to do this by hand. If you do this by hand and turn it in, I mean, I'm going to say two things. Like, wow, that was impressive, really. And two, you're damn full, because this took a long time. It's going to take a long time to solve this thing. Okay, so don't feel compelled to like write all of this stuff out and solve everything by hand. I mean, if you'd taken this class in the 20th century, yeah, we'd be doing that. But it's not quite the same class anymore. There's a lot more numeric stuff. There's a lot more computer stuff. So, you know, evolve with the times. So what we're going to do is we're going to go over to Edit, okay? And then we're going to go down and we're going to say, okay, well, we're going to edit this thing, hit Enter, okay, because it's already selected. And we're going to say we need a 3 by 4 matrix. Okay? And then each one of these, we're just going to write in the entry. So we're going to go 1, Enter, 1, Enter, 1, Enter, 0, Enter. I guess technically you didn't have to do that. Negative 16, Enter, negative 15, Enter, negative 7, Enter, 1, Enter, 48, 36, 12. And just to let you know, like if I'm going to give you a problem, like I have to be willing to do it. So I like fractions. I don't like numbers. I like this is not a friendly number. So that's like a little math teacher hint to the student. Like if the answers come out to be kind of nice, then you know you got the right answer. So let me go ahead and quit out of this because I don't know how to finish entering the matrix. That's the way I do it, is I just enter and then come back in. So back to matrix. What we're going to do is we're going to do a math thing. Okay. So what we're going to do is we're going to go down to RREF. Okay. So RREF. This is reduced row echelon form. Echelon is like a triangle. I don't know if you guys, when you did linear algebra, they usually call these numbers pivots. Okay, the main row, the main diagonal, that's called a pivot. And then here we call it echelon. And for some reason, and maybe you guys know, I don't, there's a lot of like 19th century, 18th century French military terms in matrix algebra. I don't have no idea why. But echelon is a marching thing. Pivot is when your army is, or your parade or your marching band or whatever is going around a corner. The person that's holding the line steady as they go around the corner slowly so that everybody else can stay in line, they're called the pivot. That's, you know, again, it's a parade thing from like 18th century military marching maneuvers, whatever. Calculator. So we're going to do RREF, enter, and then we're going to go back to matrix, and we're just going to select A, all right, and hit enter. Okay, and then RREF, what it does is it just gives you the pivots. It just gives you the main diagonal and what it's equal to. So A is 0.33333, B is negative 0.5, C is 0.1666666. Here's another little trick for you. You go to math, and this says convert your answer into fractions. So we're going to hit enter. It doesn't work on matrices. You better believe it. So here we go, right? My A term is a third. My B term is negative half. And my C term was a sixth. Okay? And I really do. I fully expect you guys to be using, calculators to solve. Like if you have anything more than a 2 by 2, like I am I'm not judging you poorly to say I got the calculator and consulted the Oracle, and here's my answer. Okay, that's exactly what you should be doing. Now, on quizzes, you're kind of stuck with not being able to have a lot of windows open, okay, or a lot of other technology, but you are permitted the calculator. I know the library, the CNM library, will loan you a calculator for several days now. So if that's something you have to do, we can certainly work on that. Other than that, please find yourself one of these, beg, borrow, and steal one. If you can't get your hands on a calculator, there are some other things I think we can do. I'm not sure how to do them, but maybe it's time that I learned. Okay, so I urge you to be able to get your own calculator. And when you do your environmental check, you show your calculator, like, hey, got a calculator. Like, I'm not going to say anything bad about that. I mean, that's your expected tool. Okay, so you're like, hey, I got a pen too. I'm like, yeah, you're supposed to. All right. So don't look at your calculator and think he's going to flag me for the environmental. No, I'm not. You're supposed to have one. Okay, going back, right? Here's where we set this up. This is 1/3, 1 over, what was this? S minus 3 minus 1/2, 1 over, what was that? S minus 4 plus 1/6. This was 1 over S minus 12, I believe. Are we good? We are indeed. So this is inverse Laplace transform, right? My function, my y of t here, right? This is equal to 1/3 e to the 3t plus 1/2 e to the 4t plus 1/6 e to the 12t. That's your inverse Laplace transform. Okay, so I wanted to show you that mostly because of the calculator issue, but but there we go. Let me do one more because the problem I have after this is, well, to say it's long would be an understatement. So let's start off with a y double prime. Okay, you don't know how to solve this one yet. Plus 6y prime plus 5y is equal to 0. And they tell us that y of 0 is equal to 1 and y prime of 0 is equal to 0. Okay, so let's take Laplace transforms of both sides. Okay, so what are we going to have? We're going to have an s squared, y of s, okay, minus s f of 0 minus f prime of 0. Okay, that takes care of this part. Okay, plus 6. Okay, be careful with the 6. Okay, and this is s y of s. Okay, minus f of 0. Okay, plus 5 y of s. Nothing else. And on the other side, right, it's a proper, nice linear transformation. Linear transformation of 0 is 0. Again, the way I pulled these off, the way I pulled off what my second derivative was, I looked at number 36, entry 36, s squared, f of s minus s, f of 0 minus f prime of 0. Okay, s squared, f of s minus s, f of 0 minus f prime of 0. Okay, and the reason I write it down this way is because I really want to group up my y of s's, right? So this is s squared y of s plus 6s y of s plus 5 y of s, f of s, whatever. Okay, minus, well, what's f prime? Or I'm sorry, what's f of 0? Y of 0, that's 1. So that's minus s times 1. This is 0, right? And then this one, right, that's going to be minus 6. Okay, so y of 0 is 1. So 6 times 1 minus 6 equals 0. Okay, think we're doing okay there so far. So we have an s, y of s is constant, or is common. So here's my y of s. Here it is, s squared plus 6s plus 5. This is equal to, this goes to the other side, this is s minus 6. And now we're going to isolate the y of s. Okay, so that's all we're working for here, is isolating y of s so we can solve it. Okay, so we have y of s is equal to s minus 6, s squared plus 6s plus 5, which is equal to s minus 6. This is s plus 5, s plus 1, right? Looks good. So this is a over s plus 5 plus b over s plus 1, because it's not a Laplace transform problem unless we get to do partial fractions. Okay, so here we have a s plus 1 plus b s plus 5 is equal to s minus 6. Okay, so putting together our s's, we have a plus b is equal to, there's one s over here. Our constant terms, we have a plus 5b is equal to negative 6. Solve this however you please. How about we set negative 1 here, right? So negative a minus b is equal to negative 1. A plus 5b is equal to negative 6. Those cancel. This is 5 minus 1, so that's 4b is equal. And then here we have 6 minus 1 is minus 7. Okay. Oh, sorry. Was that a positive? Oh, that was. Wait a minute. The minus. We're gonna add. We are gonna add. There it is. Okay. So please forgive me for that. This is a positive. Okay, and 6 minus, well, this was going to be a 5. Okay. B is 4/5. There's a reason you do this beforehand. Okay. If a plus b is equal to 1 and b is 4/5, right? I think we could pretty confidently say that a is 1/5. Okay, so a is 1/5, b is 4/5. All right, moving on. We can go ahead and take these apart. So this is equal to 1/5, 1 over. What do we have here? We have s plus 5. Okay, plus b, which is 4/5, 1 over s plus 1. Okay, let me just take an intermission here for a second. If you are looking at this polynomial here, s squared plus 6s plus 5, you're saying, where have I seen like 1 of something plus 6 of something, 1 of something with a 2, 1 of 6 of something with a 1, and 5 of something with like just a 1? Yeah, this polynomial here, or sorry, this polynomial here is absolutely related to the polynomial we started with, right, the differential equation. So what we're doing with Laplace Transform is we're turning a differential equation into an algebraic one, solving it, and then pushing it back into our t world. Okay, but that's exactly what's going on. Okay, so if you've had this class before, if you had part of this class before, and like, why don't you just, like, we're getting there. Okay, the other way is guess, and there's obvious answers to guess. At the end, you're not going to know these coefficients because they're your C's, your constants of integrations. So we are going to have like our y of t, right? So inverse Laplace transform. Okay, inverse Laplace transform is a 1/5 e to the negative 5t plus 4/5 e to the negative t from this one. Okay. If we were to have done this in the standard way, which we'll get to, if you haven't had this before, you don't know the standard way. You would get a c1 e to the negative 5t plus a c2 e to the negative t, and then we'd have to use this information of our starting conditions, this information, to solve for c1 and c2. So either way, you're doing linear equations. You didn't save anything. If you're in linear algebra, right, you can say, well, that's a nice, right, it's a nice vector space. Okay. It's a subspace of R2, I think. But there we go. All right, but there's our answer, right? We're done. You don't have to do anything more, that's it. So the goal, right, is we're gonna take Laplace transform both sides. 2, we're gonna work on isolating y of s or f of s, depending on how you want to spell it. There's usually going to be some partial fractions, but really what we're doing is we're just translating all of that extra stuff into functions that we can take inverse Laplace transforms of. Okay, so I'm going to write it down as like the partial fraction step, but it won't always be a partial fraction. Turn into table forms. Okay, that's what we're doing. And then 4 is we're going to take inverse Laplace transform and then present your answer. Okay, so it really is. I mean, the reason why I like doing it this way is we went to chapter 4 first. There's a lot of different conditions that you have to memorize. And when I say conditions to memorize, like, I don't know if you remember being in Algebra 1, where you have a difference of 2 squares and you say, oh, that's x minus 6, x plus 6. I don't know if you can remember going back to like 7th and 8th grade and having like a whole list of these things to memorize and to be able to identify, but that was a lot. I didn't like that when I was in I had Algebra 1 in 9th grade. But I didn't like having to memorize all of these like rules of like, well, if it's this way, then you have to factor it that way. Like, can't we just learn like a way of factoring that's going to make this so I don't have to memorize like half a dozen rules to do this? Nah, you can memorize half a dozen rules. Oh, this quadratic equation, you don't need to memorize any rules. Just memorize this formula. You're done. Oh, okay. I'll take option B. Thanks. Okay. Yeah, we're going to stop here because the next one is a long problem. Okay, so good to go with this. Okay, pretty much every problem you're going to do, some of them are going to be a little bit harder, is going to be a reiteration of this kind of format here. Okay, so very good, and I will see you on the next video. Stop.